Okay, so today you're going to be using your graphing calculators quite a bit. So you're going to need either a TI-84 or an Inspire. You can pause the video and you need to write down the directions for finding the maximum or minimum. That's actually what we're doing on the second half of today's work. But if you have an 84, you use this method, and if you have an Inspire, you use this method. Okay, and remember, you'll have a secret word at some point, so you need to write this down. Okay, so first thing we're going to do is not really related to this, but you're going to use your calculator to graph, right? We're going to sketch a general graph. It doesn't have to be perfect. And then we have to decide whether the graph goes up or down. That's telling me the end behavior of the graph. All right, so first thing we are going to do is we're going to graph this equation. I'll use the 84 for this first example. So you're going to go to y equals, and you're going to get rid of any equations that you have in there already. You're going to type in this equation. If I'm going too fast, pause it, and then you can get caught up for typing the equation in, and then you can restart the video, and then you'll be where I am at. Okay, so you should be following along and typing in all the buttons as I do these as well. All right, so we're going to hit graph. If you don't have this exact picture, you need to do a standard window. So you would do zoom 6, which is the standard window, until you get this picture. All right, so all we're doing is a rough sketch. So as you can see, it starts off, it goes up here, it probably goes above the graph, down here, probably goes a little bit below the graph, and it looks like that. Okay, so I drew on my paper what I have on my screen. When it asks you to describe the end behavior, it wants to know where would your arrows be pointing. Like, are you going to negative infinity or are you going to positive infinity? If I were to keep going and draw this graph forever and ever. So, on the left side, where does it go? It goes down. On the right side of my graph, right, this is my left and this is my right. Don't get confused, right? This is my right. On the right side, it goes up. So that's all it's asking you to do. All right? But let's go back and analyze, like, why does it go up and go down? Well, if you look at the degree of my function, I'm looking at the highest exponent. We did that, I think, back on day 1. So it's a third degree. Okay? And my lead coefficient is a 1. It's positive. All right, so we're going to come back to this actually after we do problem number 2. Okay, so let's do problem 2 using the Inspire. Okay, so you're going to graph. Hopefully you could see this. So I'm going to go back to my home screen, and there's a little bit of a glare here. That's better. Okay, so I'm going to go to a new document, and I'm going to add in a graph. All right, so I'm going to type in my equation. It's negative x to the third plus 5x squared plus 2x minus 2. Alright, so here's my picture after I hit enter. And you're just going to draw a rough sketch. So as you can see, it goes down and back, down, back up, and then above the screen. So I'm just going to try to draw as best as I can what I see here. So it goes a little bit above and then back down. Alright, so again, all I need is that graph. Once I have this graph, I'm done with the calculator. So now it's asking you what happens on the left side. Well, the arrow would point all the way up, so it would go up. On my right side, the arrow points down, so it goes down. Alright, so let's go back and look. What's the degree of this? It's a cubic again, right? It's a third degree, and my lead coefficient this time is a negative 1. So we have a third degree polynomial. That's an odd degree. In odd degree functions, your left and right side behavior will be opposites. So one side will go up and one side will go down. Well, to decide which side is which, you look at your lead coefficient. If it's positive, basically your graph is going to have a positive slope. it'll start off going down and it'll end up going up. So a positive slope would end up on the right side going up. If it has a lead coefficient that's negative, it'll have a negative slope. So on the right side it'll go down, and on the left side it would go up. Alright, this will work for any odd degree polynomial. It doesn't have to be only cubic. Alright, so look at the next two problems. Alright, so we're going to go back to the TI-84. Or actually I have TI-83 plus, but same thing. So I'm going to go to y equals, type in my equation, x to the fourth minus 2x squared minus 4. Okay, I'm going to hit graph, and I'm just going to draw a rough sketch. So I have kind of like a W shape, right? Alright, so now I figure out what happens on the left side. It goes up. On the right side, it also goes up. Alright, the degree of this function is 4, which is an even number, and this time my lead coefficient is a positive 1. So we'll come back to the degree and the lead coefficient in a minute. Alright, so let's look at this one again. So I'm going to go back. If you want to, you can start a new graph. Otherwise, you could just hit tab and up, and then that'll get me to my first function. So I'm just going to delete everything I have here. So I'm going to type in negative 2x to the fourth minus 3x squared, no, 3x cubed, plus 2. Alright, so I'm going to hit enter, and now I've got my new graph, which is kind of like a upside down W. So I'm just going to draw, kind of looks like this. Right? Okay, so here's my graph. On the left side, where does it point? It goes down. On the right side, it also goes down. Alright, and my degree is 4. This time my lead coefficient is negative 2. So if it's an even degree, then my end behavior should be the same on both sides. Right, my left side went up in problem number 3, and my right side also went up. And in problem number 4, both sides went down. Okay, so they agree. Either they both go up or both go down. Well, how do you figure it out? Look at your lead coefficient. My lead coefficient was positive, so both of them go up. That makes sense, right? We've done that with parabolas. Lead coefficient here is negative 2, so both of them should point down. That's it. All right, the next part is identifying the local max and the local min for each function. All right, so this is going back to the directions here. So I'm going to do it kind of quickly, but if you need a cheat sheet, just follow these directions that I wrote down. All right, and our secret word today, well, I'll do that at the very end. All right, so problem number 5, we'll use the TI-83, 84. So I'm going to go back to y equals, type in my equation. Okay, once I have this, I hit graph. I'm just going to draw a sketch. So when it asks for the local maximum minimum, it wants basically the vertex of these little parabolas. So this would be my local maximum. This would be my local minimum. Right? My grand overall maximum is up to positive infinity. My overall minimum is negative infinity, but it doesn't want that. It wants just within this little screen. All right, so I'm going to do the local max first. All right, so I'm going to hit second trace, and if I want my maximum, I choose maximum. Right? We've used this menu before. We've done zeros, we've done intersections, so you're just choosing maximum. Okay, so all you need to do is set your boundaries. So you know that you need to be somewhere to the left, hit enter, be somewhere to the right, and hit enter. And see these two arrows? Your maximum should be in between those 2 points, which it is, so you don't have to do a guess. If you want to, you can put your cursor up here. All right, so the thing you need to write down is only the y coordinate, and we're going to round to 2 decimal places, so 3.30, so just the y coordinate. Okay. All right, same thing for finding my local minimum. So I'm going to hit second trace, calculate my minimum, and I'm going to make sure my cursor is a little bit to the left, hit enter. A little bit to the right, hit enter. And then you could put your guess, hit enter. And that is negative 5.30. Alright, I'm going to do a couple more. I'll do one more with the TI-83, and then I'll switch to the Inspire. Alright, so we'll just do this one. Alright, so go back to x to the 4th plus 3x squared minus 2. You have to go to y equals and then type in your new equation here. Okay, so I'm going to hit graph, and a rough sketch of my graph is here. Notice this one only has like a U shape at the bottom, so you only have a minimum, and in this case there is no maximum. So for this one we could say there is no maximum. That makes it easier. Alright, so I just want to hit second trace. I'm calculating my minimum, and I just need to move my cursor a little bit to the left. This is setting your boundary. So you're saying, okay, within this range from the left to the right side, within these two arrows, what's the lowest number that my graph touches? And in that case, it would be negative 2. Okay, so let's do maybe one of these with the Inspire. Alright, so I'm going to hit tab and up to my function number 1, and I'm going to delete this old equation, and now I've got x to the 4th minus 5x squared plus 9. Alright, so I'm going to draw my graph, and I've got something like that. Okay, so this goes a little bit outside of my window. Alright, if you're doing this on this one, right, you're also going to be a little bit, actually no, this one fits in your window. Here, I'm going to change my window. So my window settings for this one, I'm just going to zoom out. Okay, so now you can see it a little bit better. Alright, so we have this, so basically we have a minimum here, and it's actually going to be the same number on both sides, and here I have a maximum. So what's nice about the Inspire is the same thing on the newer calculators. You're going to get like a shaded area that's going to show you. So you hit menu, go to Analyze Graph, and I'm going to do the maximum first because that one's going to be easier. So in my maximum, I'm just going to move my mouse somewhere to the left, click on it, move somewhere to the right, click on it, and you can see the shaded gray area. It says 0, 9. So my maximum is 9. Right? Okay, I'm going to redo it. So menu, Analyze Graph. This time I'm going to do minimum, and I'm going to do this one over here. It doesn't matter, you'll get the same answer. So click somewhere to the left, somewhere to the right. As soon as you hover over it, you see that dot come up. So you get 2.75 as your local minimum. Alright, so I'm going to do that last problem using back to this calculator. Alright, so go to y equals, type in your equation. Alright, your secret word for today is going to be pentagon. Okay, so you can write that down. Alright, so let's take a look at my graph. Alright, you're just drawing a rough sketch, so we have something like this. Now, I do need to change my window for this one. Okay, so I'm going to go to my window, and I'm going to maybe make this go to negative 30. Okay, so that way, you probably didn't even need to make it that small, but at least now you'll be able to calculate it. Alright, so I'm going to do second trace, calculate my maximum, and go a little bit to the left, a little bit to the right, hit enter, and my local max is going to be negative 2.91. Alright, my local minimum, if you go a little bit to the left, a little bit to the right, hit enter, you're going to get a local maximum, or local minimum of negative 14.09. Okay, hopefully you followed along. Again, this is a lot of stuff on the calculator, but much of it is similar to what we did last semester, so you should be pretty familiar with your graphing calculator at this point.